So we are going to talk about 10 Java security best practices or Java security practices they didn't teach you in school. Because what I found out when I was back in college and then in university is that we learn how to develop software and not so much how to develop secure software. And that is weird, right? We do a lot of things on code quality, and that's more or less on how to make code better, faster, and stronger, but not so much security. Security maybe a bit, but it's not a real subject, if you know what I mean. I want to start with this picture, and hopefully you can see it. This is a picture of King's Cross train station in London. And of course, you've probably seen this. This is a reference to the Harry Potter movies. And it's platform 9 3/4, which is strange because what the heck is 9 3/4, right? I mean, I wanted to actually call this talk 9 3/4 Java security best practices, but well, it doesn't sound that good. But the point here is that Harry wanted to go to Hogwarts. He needed to catch that train, but 9 3/4 isn't the real platform. Only if you know where to go and where to push with the right right amount of force and at the right time and with the right tools, you are able to go through that wall and go into that hidden platform. And if you look at it, there's a parallel between that and software, right? Because if we look at it from a functional perspective or a functionality, the software works fine. We have tests on it and it completely works. But if you push with the right amount of force, with the right amount of tools, with the right injection or something in the right spot, you may be able to do or see some parts that are not actually meant to be there for your eyes. Or you can actually do things. And that's what this is about. Well, I already had a brief introduction, but I have this most boring slide ever because nobody wants to know who you are. Still, I'm going to bore you with that. I'm Brian. I'm developer advocate for Snyk. Snyk is a security company / security tooling company. We provide security tooling for developers to make it a bit easier. I'm doing a lot for the community. I'm a colleague for both the Utrecht Java user group and the virtual Java user group. We do a lot of virtual sessions, so this is quite common for me. But on the other side, normally I'm in Devis place that I'm hosting these things, and now I'm giving one of these sessions. My DevSecOps is also a community online, which focuses not so much on only Java, but on DevSecOps in general. So security, development, AppSec, InfoSec. If you want to know more about that, you can go over there. And I'm a Groundbreaker ambassador. But that's enough about me, because we are going to talk about security. And the first thing, if we ask people like, who is responsible for security, people point to each other. Because although we do DevOps, there is still a separate kind of security department in most companies, right? But if we ask people, and we did this in the state of open source security, which was a big survey in 2019 for us, and we asked people who's responsible for security, most of them say it's a shared responsibility between all of these. Well, between security team, developers, operations. But if we look at the answers, this was what people said. 81% of our respondents said that developers need to take their fair share in security because we basically built the stuff. So we are responsible for that code to maintain it. And think about it. When something goes wrong, the code comes back to you or the program comes back to you. You need to fix it and then you deploy it again, because nowadays there is no such thing as a real operations department. No, you do it yourself. But it also needs to be practically the way with security, right? Think about it. We create the stuff, and if we think about security issues from the beginning, that might help us. That's why I'm going to talk about security issues. And basically what I did is I took a look at the OWASP top 10, and that top 10 was created in the last version of that top 10 was created in 2017. And I looked at it from a Java perspective, and I saw something strange. There are still a lot of things in that top 10, so the top 10 most common vulnerabilities, that are there for ages. If we start with the first one, we're starting with SQL. And SQL is something we might all use. Or, well, nowadays, if you're a hipster, you're using some NoSQL stuff. Anyhow, that doesn't matter because it also hands to NoSQL databases. The point is if we look at the OWASP top 10, SQL injection is still at the top. The problem with SQL injection is that people think from a functional perspective, like how to create stuff, but do not remember how to work with that. And it's still one of the most common vulnerabilities. For those who don't know what SQL injection is, I will just give you a brief demo. Oh, that will be the second one. Anyway, say I have a small application over here, right? And what I can do over here, I have a search engine for users because I'm an administrator of this stuff, and I can search users by nickname. So say I want to search for Superman. Great, that works. As I see here, I can use the percentage sign as a wildcard, so I can also search for Batman. Amazing, that works. But this implementation has a SQL injection or is able to do SQL injection. You're able to do SQL injection over here. Let's just say just do something like this. What I'm doing here is with this mark, I'm closing the first where clause in my SQL injection. I just insert a new one and I say where first name is Bruce. By submitting it, of course, I will get the same result over here. But that means that this query they're able to do things like this. Say this one. I'm not only closing, in this case, the where clause, but I'm closing the whole query. And I'm opening a new query because in most implementations, and this is just a regular implementation of using a SQL statement, I can create a new statement. So instead of just searching, I'm just updating every user and setting their first name to Moha. And by doing this, you will see I have no result because, well, it doesn't return a result. But if I'm looking at the results over here, you see that I overridden every first name over here, which is something we do not want. Let me go into this classic example. Let me see if I can. Yes, over there. And I think it is this one. No, it is not. It probably is this one. Okay. So you can all see my code over here. This is a very small application we created for a workshop. And what I'm doing here is I have this user controller. And this user controller goes to a search repo. And the search repo is the interesting part because here is the code where I say find user by username. And I basically create a query, select star from users where username is, and I simply dump in my parameter. The point is, I do not make a distinction between the actual query and the parameter. The query is part of the parameter is part of the query. So that's why I am able to do these kind of things. The easy way out in this case, of course, is query parameterization. And we can do query parameterization in Java with a so-called prepared statement. So let me just do that. So instead of a statement, I'm just not copy pasting it. I'm just making a what is called a question mark. And instead of a statement, I'm calling it a prepared statement. So the prepared statement, and I need to change this one into prepared statement based on the query. Great. What I can do now is in this prepared statement, I can set my stuff to statement.setString. So I bind my parameter in this case, and this will be the first parameter. You can use many parameters to a string. So I know that the string that's coming in, the parameter in this case, is bound to a string and will not be part of the query itself. So by doing this, I bind it to a string. I can bind it to a number. I can bind it to basically all primitive objects we have in Java. So by doing this and creating it over here, I am able to rerun. Yes, stop and rerun. And this is also always praying to the demo gods to make sure that things work. And it seems to start up. So that is a great thing. Let me go back to my thing over here. If I'm doing things like that again, and I'm trying to update all these names to muhahaha, and again, it doesn't give me any result set. And you see that because it is bind to a string and not part of my query, I am not able to open another query to update all my records in my database. This is the old-fashioned way to do it. And most people are using probably Spring or Spring Boot applications. And if you're using Spring Boot or Spring Boot applications, you can use things like this, right? You can just extend the CRUD repository. Luckily, if you're using this and you don't need to maintain an old application, you can just use things like this. You can implement it like this way and say something like find user by username and give the username as your parameter. Spring Boot CRUD repositories username, I'm sorry, will take care of that query parameterization for you if you're using the default stuff. If you are inserting queries manually, which still is possible, you still need to be careful of this. So this seems like an obvious one, but use this as well in things like, say, code reviews. You probably need to work with youngsters or with new junior developers. Take this with you in how to look at code, not only how to write code, but educate people that there is a difference between just creating a query and making sure that if you do it in the old-fashioned way, like here, that you make a distinction between the parameters and the query itself. And this also hands for NoSQL databases, because in many cases, NoSQL databases implement some sort of QL language, SQL kind of language to do these kind of things. And if you still intervene your parameters with your query itself, you have the same problem. Well, that was an easy one, right? Let's go back to my slide deck. Second one we're going to talk about. The second one is OpenID Connect and two-factor authentication. And why? First thing is why? Because most important part, identification management or identity management and access control is very hard. I mean, if you need to create it yourself, please create a new team to do that, to make sure that that is actually done properly. If you don't need to do that yourself, it is a perfectly legitimate option to use third-party things like, well, I will say Google or GitHub or whatever third-party authentication part you trust. And why? We are also deploying our stuff to third-party cloud instances. Why not do the same with identity management? And how does this work? Well, if we look at an application, I mean, if we look at the OWASP top 10, it is still a large problem to work with identity management, right? There are many things you should take into account when you create the authentication yourself: storage, password, encryption, etc., etc. But in many cases, it's much easier to use an OpenID Connect provider. When OpenID Connect is available and when it's there for you, for instance, in this scheme I'm going to Yelp, and instead of logging in with my own credential, creating a new stuff, I will be redirected to, for instance, Google, and Google will take care of the identification for me. If that is done, it will provide an access token back to my application, and it will have an endpoint with user information available. So now I do not have to take care of this anymore, and I do not have to store these passwords anymore, and I basically leave that up to the other parties. So I'm eliminating things like password storage. I'm eliminating things like password encryption and the point that it can be that people can break into me to steal that, right? So the point is, because identification is hard, we can, the best way to do this is to give that away or to help us and use a specialized third-party product to do so. If I'm going into the implementation of it, and say you're using a Spring Boot application, it is quite easy. If I'm using a Spring Boot application and based on Spring 5, I can simply use it into my configuration. By using the configuration like this is an example. I now use two providers. I use GitHub, for instance, and I'm using a Okta client. And why I use Okta? Because Okta gives me the power in this case, and there are many other providers. I'm not bound to Okta or whatever, but I'm just using it because I now can do everything myself. I can create users there and I can do the management in there. So now they will take care of the authentication for me. And the most important part is we do not just want to have authentication. We want to have multi-factor authentication or two-factor authentication, which basically is the same. Multi-factor authentication only means that we have multiple steps. Two-factor authentication, it already says it has 2 steps. So it's a subset of each other, right? And what we want is if somebody else takes care of that, do you want to implement multi-factor authentication yourself? Probably not. And multi-factor authentication is quite, the interesting part is quite simple. You know something and you have something. You know something is knowing the password, right? And then you need to verify yourself with something you have. That can be your mobile phone or things like the old-fashioned token you have from your bank. Like, you remember these tokens that you have this machine that you have to put your bank card in, you have to push a few numbers and you get a pseudo-random code, and then you have to put it in. That's because now if your password gets stolen, it's still not valuable if you do not have the other part. By using a third party that implements OpenID, you have an easy way without taking care of all the problems. You have an easy way to implement this security feature with multi-factor authentication into your Spring Boot application by just having the configuration I just showed you in the slide before. So don't go into the hassle to build it yourself unless absolutely needed, right? And most of the times when we build application, we do not need this. So integrate with OpenID providers like GitHub or Google, or, well, in this case, I just created a free dev Okta account, and they are, for instance, able to do multi-factor authentication for me. And now the whole incoming stream is quite safe. Next one, dependencies. And this one I find always interesting. Because if you look at your code, yourself, and you look at the binary that you put in production, say this is the binary you put into production, how much of this code is actually the code you have written? Think about it. How much of this big yellow ball is the code you wrote? Probably this, right? We depend heavily on frameworks, libraries, multiple libraries that depend on other libraries. And a bunch of this stuff, or most of the code that you put into production, is not yours. And think about the other thing. If you create code yourself, or your team creates code, do you blindly put it into production? Hopefully not. Hopefully you all have something like code reviews, or you do pair programming, or you have some stuff in place that scans the code that you create, right? Because, well, people can make mistakes. Think about how you work with dependencies. Are you doing the same thing? And are you reviewing the dependencies? Once it's in, it never comes out? What is your update strategy on that? Don't know, right? So I will give you a small Spring example because, well, everybody's using Spring, I guess, or it's at least one of the most widely used frameworks. This is a Spring serverless example, and it has a bunch of code. It, of course, is a snippet, but we created this application and with 222 lines of code. These 222 lines of code wasn't the most pretty code, trust me. We created it for demo purposes and it was ugly. It had a lot of duplication, but just to make conversation, right? It has a bunch of dependencies. To be exactly 5 direct dependencies I put into my manifest file, in this case, a Java POM file. These 5 dependencies, they will come back with other dependencies because, as you know, if I pull in something from, well, say Amazon AWS or the Spring Framework, a dependency depends on dependencies, depends on other dependencies, and it goes several layers deep, right? So that means that these 5 dependencies will end up in 54 dependencies. And now the $1 million question, how many lines of code do I put into production with my very ugly 222 lines of code Spring serverless application? Take a few seconds to think about it. None of you has to answer because, well, you're all muted, right? But just for the sake of argument, what do you think? This many. It's almost 500,000 lines of code. So you can be strict on that 222 lines of code and optimize the hell out of it and look at the security issues there. But what about the other 500,000, right? And the point is, attackers are targeting open source packages because if an open source package is vulnerable and many people are using it, I have a potential of many victims. Say I find a problem in, well, something in an Apache Commons library. Because millions of people are using that, there is an issue over there, and I have millions of targets just to try it out, to see if that hex works on all the endpoints in the internet. I can basically write a script on that. So let me show you how that works, right? Say I have an application over here, and this will be this one. This will be a very small Spring application. And this Spring application is nothing much. It's a grocery list. It has an item, and this item consists of an ID, a name, and a cost. This ID is pre-generated, perfectly fine. If I start up this application, you will see that my grocery list is compiled. Beans for 50 cents, milk for $1.09, bread for $1.50, etc., etc. Nothing interesting again. Then we have the repository. Well, as you can see, I extend the CRUD repository because I'm lazy. And I do not want to recreate everything again and again and again. So I use this, and it's quite easy to mock this, to make a POC on it, and ship it, right? Because what I do over here, by having these things like find by name, I already have the regular CRUD functionality that is available. By using Spring Data REST and this annotation, I can recreate I can transform my CRUD repository into a REST repository, which is awesome, because if I do that, I can go and work on my front end, basically, right? I do not want to build these things over and over again. So let me run this, and let's see if this works. So what I basically need to do, I just have a bunch of annotations. I insert, something is already running. And what is the issue over here? Address is already bound. Oh, it's port 8080. Let me just make sure that everything is shut down. Is there another application running? Maybe this one is running. Nope, it's not running. This one is running. Could be also a problem. And let me try again. So the point what I want to say is I'm just using the stuff as how it is supposed to run. So now it runs, cool. And I can go to my application. By going to my application, I use localhost 8080 as we saw, and I will be redirected to my hell browser. And what I do with my hell browser over here, I can find something. Like if I do items 1, this is just a way to show you how this works. I will have beans, which is the first item in my list. Cool. I can do the search thing, search things like find by name, and name is beer. which is still cool, and it will give me beer for $5.99. Amazing. But there is an issue here. Of course, there's an issue. And that issue is part of the Spring library. The Spring library I'm using has a flaw, and that is in that Spring data rest stuff. So let me go into my exploits. I tried to prepare it. And what I'm doing over here is I'm going to show you an exploit JSON. So if I'm getting this one, Spring exploit JSON, let me redo that and let me enlarge that so you see it. What I will do here, I will do a curl request over here, and I will give this body, and this body is just basically JSON. But the point is, in this Spring application, it is possible, or Spring has how do you call it? Has a language has SPEL, the Spring expression language. With Spring expression language, I am able to create new objects or alter objects that are already running, basically. And what I'm doing over here is I'm trying to create a new object by creating a new runtime. And that runtime, I can give it basically anything I want. So if I do this, I'm doing a curl patch request, right? I am calling the runtime, and I'm executing the command env. And what I'm doing with that is I'm calling it basically on a endpoint that already exists and that is normally of no use. But there is a problem in this application when I use a patch request with this body. So by basically doing this, I can use and I can look at the environment variables of my application. What you can see here, of course, it works on my local machine. I will display all the environment variables that are here on this machine by simply knowing this hack and by only knowing this frame or only using this framework in a normally legit way. But I don't know that this problem was there. And it's there. So you need to find out how that works. If I'm using libraries that have an issue, right? So how do I do that? And I can do that for multiple purposes. I'm here in the root of my project, and of course I'm using my own tooling for this. And what I'm doing here is I'm looking at the Maven dependencies. I'm letting the Maven dependencies or Maven create my dependency tree and try to look into that tree, its direct dependencies and indirect dependencies, and see if there are problems. This is a command line tool, and it's easy to use on your local machine. But what you see over here is that there are a bunch of problems. Let me go over here. For instance, I am using Spring 155 build snapshot. First of all, never use a snapshot version in production. If I update it to 2.10, I will get rid of all these problems. 2.1, sorry. Here we have the arbitrary code execution problem I just showed you. It is there in Spring Starter Data REST 155 build snapshot. If I update it to 159 release, then it's fixed. So you need to have this stuff in place, or some sort of stuff to scan your dependencies in the way you are comfortable with the fact that, am I not using something that is going completely berserk if I just deploy it? Because once it's out, people can find it. And once it's out and you are there, and you don't use it anymore, and you're not aware of it, you can be, well, broken, basically. So in this case, I connected my project to, or my repository to Snyk because, well, I do not do work on it every day, but on a daily basis, it will scan my repository and it will see what the problems are. And it will give me upgrade advice on which version is vulnerable and where to upgrade to. It can give me instance like, where is the actual problem? So make sure that you have stuff in place to scan your repositories, and not only when you go to production, but also when you are in production. Make a snapshot and scan it on a regular basis. Scan it on your local machine, catch it early, right? All right, that's enough. Next one, because we have a bunch. Sensitive data. First of all, we're going to talk about the least privilege principle, because we all know what GDPR is, right? We're living in Europe, and GDPR is a thing. We have to make sure that our privacy is there, that our privacy is granted, that we have, that people cannot just see our stuff. Can you imagine that if you are in a hospital and people are using and you have an issue, and it's okay that your doctor sees the issue, right? But not everybody in that hospital. Am I correct? So we need to make sure that the people who need to see it, and the people who don't need to see it don't see it. And it sounds simple, but let me go into a small example. Say I am having an application. Which one shall I use? This one. I'm having a user controller. It's a simple, I need to shut down the other one first, because or else I will get collisions. This one is shut down. Where is my Spring Boot application? Here is still running. Move it. Cool. So I have a simple application over here that can show me users, and the users contain IDs, first name, last name, and addresses. So if I am running this application, and I need to run the whole Spring Boot application and not just an example, I will have an endpoint with three, where I have access to 3 users, and just to make it simple, right? So let's say I will go to localhost 8080/users. And you will see I have my 3 users in my JSON output. But what's wrong with it? Well, my front end does not use the address. Well, if I have the address, for instance, together with the first and last name, I might have a PII problem or a GDPR problem, because now I can connect real people to real addresses, and that is considered an issue. So as my front end is not using that address, I need to make sure that it's not in the output. And trust me, in many cases, we provide too much information in the raw data that we actually do not need in your front end. So say I do not want to output the ID, and I do not want to output the address, because the address, well, it's PII data. And for instance, the ID, if I have that ID in combination with, for instance, a username, I can use it maybe in another endpoint to gather more data. And if I connect all these endpoints I have in my microservice architecture, I might have trouble as well. So only display the data that you actually need for that front end, right? So getting back to this user controller, what I basically do is I just output whatever is this entity, and it marshals the JSON for me. Well, I can simply, by using a JSON ignore, JSON ignore, I think it's this one. JSON ignore over here, and for instance, a JSON ignore over here, I can simply prevent this. So now in my endpoint, I only display the ID and the address. And you just, tomorrow, if you work with this, just take a look at the actual endpoints, and if you do not display too much, right? Because if I do it now and I just go to users, you will see that it only has the first and last name, and that is maybe actually I need for my application or my mobile app to show what I want to show. So make sure that the raw data doesn't show more, because people will try it, that the raw data doesn't show more than needed. But then there's the next thing, because can you see this lower part of my screen? There's a log file. And most of the time, we know that logs are persistent, that logs will be saved, logs will be centralized, and we can look at it. But even the administrator is maybe not allowed to see things like the address or the ID. Say it's not allowed to say the address, because now we still have a PII leak or a GDPR leak. And I want to do that. I'm using, in this example, I'm using Lombok, and you can think of Lombok whatever you want. I'm not going into that discussion. Some people love it, some people hate it, some people are Kotlin hipsters. Doesn't matter to me. But the point is, I do not want to print this address into my log because, well, now it's an address. Next time it's a credit card detail. So saying, for instance, I'm using Lombok, and I can simply make sure that by using the toString annotation from Lombok and exclude it, because, well, I like to code less and do more. And by rerunning it, stop and rerun, you will see that the address will no longer be shown in your log files. So not only think about the output that's going to the user, also think about the output that goes into your log file. Just to prove it, over here, and the log file now only shows the ID, the first name, and the last name. The moral of this part is make sure that you do not display too much, not even in your log file, because logs are most of the time persistent and logs are indexed. So that might be an issue with the I want to be forgotten right with GDPR, right? All right, next one. Input. Well, users can do a lot of nasty things, right? If a user is there and he or she can input stuff, then it can be nasty. And we need to consider it nasty because we have something like this, cross-site scripting. For those who don't know what cross-site scripting is, basically I want to insert data and want to be executed on another person's machine. In this case, most of the time, cross-site scripting is that I'm inserting JavaScript in a form, and I want it to be executed on the end user's machine. So the next person that sees that website, the JavaScript will be executed, and it does something to it. And if we look at the rules for cross-site scripting, then we can look at rule 0. And rule 0 from the OWASP Foundation is how to prevent XSS is never insert untrusted data except in allowed locations. Okay, so we're not talking only about users. Allowed locations, fair enough. But think about machine-to-machine connections. Like if you are not connecting, if you are not in charge of that data, but you're importing data from another machine because, well, you have something over the line with JSON or objects or streams or whatever, or for instance, you get stuff from your database. Say, okay, I'm only displaying stuff from my database, right? I do not have to take care of that because I own that database. But what if somebody had that backdoor into the firewall, get into your database, not your application, but into your database and insert some JavaScript over there? If you are not sanitizing this stuff and you're displaying it, the cause and the problem are in two different areas, but you still have an issue. So basically, you need to look at where does your data come from? And is that data allowed? How do we need to do that? Well, the answer is simple, but still complex. Sanitize everything. Every input that is not trusted, and you have to look at from an architectural point of view, what stuff is trusted and what is not trusted. You need to sanitize it. And sanitization can be easy. Sanitization can be done with just using a simple library, right? So if I'm having this application again, you've saw this demo application and to insert users, and I can add a new user for, oh, it's not running, of course. Good job, Brian. You need to make sure this stuff is running before you actually try to demo it. Anyhow, I'm trying to run it, and I'm giving you an example what XSS is. So I'm over here, and I want to add a new user, which is cool. Now, well, let me add a new user. I will use a new superhero called Snickman, and it's, of course, it's me, because I'm a lame-ass dude. Last name, I also have a last name. Password 123456 because I work at a security company and it sounds pretty good. And I can do something like this. Well, this is just an alert, right? When it pops up, it works. But what do you think of this one? I'm alerting the cookie because if that is available to me and the CQRS holder, CQRS, talk to me, the cross-site request forgery headers are not in place, I might be able to read it. Let's do this. Of course it works because if I submit it, I do not do sanitization on these fields. And if I look over here, I will see that my token is Java Code Workshop 12345. Awesome. So instead of actually inserting a comment, I'm inserting JavaScript and it works. Well, you might have these problems everywhere and you might need to sanitize stuff, but how do you do that? Do I need to create my own regular expressions? Because if people can get my token ID, for instance, and can display it, they can also send it to another machine and maybe even steal my session, right? And I don't want that. And I don't want JavaScript to be active and that they can insert it in a comment. So let me work this out. I am here, this user control, and I will do it in a very ugly way. Trust me. What I'm going to use over here is, if you see in my POM file, I already inserted something. I am using the OWASP encoder. I'm using this simple encoding library that the OWASP Foundation used and published. And it is able to encode a lot of stuff, from this to that, from plain text to something available for Python or for Java or for JavaScript or for HTML. And I will do the HTML version in this case. So from the user controller, I did a very bad job by just using the user and actually directly saving it to the repository. Normally you have a layer in between, but just for the sake of argument, say I want to say user.set comment and I want to sanitize this. Say I do, what is it? Encode, if I'm not mistaken, .encode for HTML, and I'm using that user.get comment. Yes, this is ugly, but the point is that I can use this encoding library to make sure that the input string is sanitized in a easy way to HTML code that is non-intrusive and cannot be exploited. So by rerunning this, and I basically want to say this, take a look at these tools that are available. This one is, again, is from the OWASP Foundation and will work for you. So why not use it and use it in your day-to-day life to sanitize the stuff? Because we need to sanitize it, as you can see. And let me do the same thing again. I will insert Snickman and give it a name, doesn't matter. Password doesn't matter. And the comment is, again, that document.cookie, right? If I submit it now, you will see that it will be sanitized. And if I see over here, then we will display the sanitized version of this HTML. So what I do over here, I sanitize it and I make sure before it enters my database to do so. But also take care of if somebody else can post into your database or you see your database can be a liability, you can do it the other way around. Everything you publish into your website, you need to sanitize as well. And this, of course, sounds a bit dramatic, but just take a look at your architecture and look at what kind of streams are going in and out and where you specifically need to do this, because cross-site scripting, it's nasty. All right, sanitize everything. It almost looks like my mother and says, like, clean up your room. Next one, XML parsers. Normally, I ask people like, who uses XML, still use XML? And there probably are a lot of people that need to use XML because, well, we have a lot of applications that are a bit old. But by default, every XML parser in Java has external entities enabled. And that means that if I can control that XML that goes in, I can do an external entity injection. That's more fun to show it again. This one, XXA example. So what I'm doing here, I'm having a very, very naive implementation of a sex parser. And the sex parser basically will output all starting elements. And if its starting elements contain something, it will print what's in that starting element, right? And I am looking at this file, songsqueen.xml. Let me see where I posted that, songsqueen. And this will be my XML I will be parsing. So Queen with Bohemian Rhapsody from the album A Night at the Opera, another one. Doesn't seem too worrying, right? So if I do this, and I run this application, it will basically show me my XML. And as XML, you will see it starts with the text songs. It has a song, an artist, a title, whatever. And you can do whatever you want in an XML parser. And I'm using the sex parser, but also the dump tree parser or any other parsers in Java have the same issue I'm going to show you in a second. Because say I'm not using this XML file, I am using the other one I prepared. And let me show you that one. Because external entities are available, I can import stuff. And by doing this now, I am not importing another XML file or XSD file. No, I'm going to my etc/password file, and I'm importing that file, and I'm actually outputting that instead of the artist. First time I saw this was, is this possible by default? And the answer is yes, this is possible by default. So by basically doing a doc type insertion like this, external entity insertion like this, I can show a file in your system and say that file, say that name normally is outputted into a website. I can look into it and I can see what is there. So by doing this, instead of, well, let me just run this and you will just see. You will see instead of the name of the artist, I will have the output of my passwd file, and I can basically go to any file I want, because external entities by default for every XML parser in Java are enabled. So if this goes somewhere into a database or is displayed directly into the screen, I can just read out what's in there in the system, which is a vulnerability. And the easy way out is just implementing these 3 lines for the sex parser. If I do this, and I just uncomment them, and I basically make sure that both on the factory and the sex parser itself, it will set the external entity features to false. So I'm not allowed to do external entities in whatsoever. And these things are just, you can look this up on the internet, which one you need for your specific parser. So by doing this and running this application again with that faulty or with that XXC intrusion application, you will see that the artist now is not printed because external entities are not allowed anymore, right? So if you're using an XML parser, just look if the external entities are enabled for the parser that you use. And for most parsers, or because by default it's true, people are just using that, and that's a fault. All right. Did this Java serialization? Oh, that's awful. Because Java serialization is called the gift that keeps on giving, and that's for a reason. Because, well, as we all know, this is a problem for years, and even the architects find out that it's a problem, and everybody hates it, and they're now trying to solve this to get the whole serialization part out as part of Project Ember. Anyway, basic serialization. You have an object, we create that into a byte stream, and we can use that byte stream to send it over a line or publish it on a database, a file, whatever. That's serialization. Nothing more. Deserialization is basically the other way around. If you have that serialized object, or you have a file, you transform it into a byte stream. That byte stream we try to create into an object, and that object you can use in your system. And deserialization is done with the Java serialization API, or with any marshalling and unmarshalling application, because XML marshalling is also basically serializing the stuff, making from an object a byte stream, and it doesn't matter in what case. But we're talking about Java serialization. The point with Java serialization is this. If you deserialize the stuff, you need to call the read object. And the read object, the one here, is already called before it is parsed or it is cast into the actual object. So that means, because, well, let me simplify it. Serialization uses a lot of reflection. And the read object is already called, and the object is already basically deserialized. So a lot of stuff can happen because all the checks are probably in the object itself if you deserialize it and you want to do it in a proper way, right? Point is, you basically can't. And there are more problems with serialization. And I oversimplify it, trust me. I really oversimplify it. Serialization uses reflection and uses references to other objects. And if that reference is already there, it reuses the reference because, well, we probably need to serialize this stuff 2 or 3 times. We keep that reference and we use that again and again. So what you would say normally, if you deserialize this data holder, you would suggest it has a reference to a data object, right? Yes and no. Because basically, if I make a faulty chain of serialization or deserialization object, if I'm able to insert an object that is, for instance, a child of date, I can do the same because it keeps that reference. So if I have this somewhere in the chain before that data holders are deserialized, it will keep that reference and it can do something completely different, which I'm not expecting. And that's the problem with serialization. And there are a bunch of problems with that. And we can talk for hours about what the problems are with serialization, but we do not have the time. If you want to go more into that, I would say go to this talk. This talk is by well, the guys who basically wrote the stuff, Brian Getz and Stuart Marks. This one is URL from DevOps Belgium 2019. And you need to go into that serialization, what all the problems are with serialization. But how to prevent that? Because sometimes, basically, I want to say, don't use serialization. If you don't need it, don't use it. But sometimes you need to implement serialization because you are inheriting something and you need to make it, because it's implementing some interface or it's implementing or it's extending some object, you by default have serialization, right? If you want to prevent that, there is an easy way. Preventing serialization is hard, but to make sure that it cannot be deserialized is not that much of a problem. Going into this one, serialize example. What I'm trying to do here is I'm trying to serialize a node and deserialize a node. Here I'm serializing it, writing it to a file, and here I am deserializing it. So if I'm running this one, this works perfectly fine. But I don't want it to use it. Oh, it's not. Well, never mind. I made a mistake over here. What we can do over, oh, it's not implementing serializable. Of course, implements serializable. Now it should work. But the point is, because that read object is already called before it will actually be casted to the node, if there is a faulty object in my class path somewhere, we can do a lot of things. And you might think like, well, that never happens. But just count the amount of classes that are in your class path. And if there is a vulnerable class that might execute something different out, that can be part of that whole deserialization chain. And you will get lost probably. What I can do, for instance, is make sure that the read object stuff for this one is not available. And by doing this, of course, I need to implement this one. I'm making sure that deserialization is not at all possible for this one. This is one of the hacks that one of the things that OWASP is telling you, like, if you implement this private method read object, and yes, it's private, but because the serialization and deserialization use a lot of reflection, you can prevent serialization or deserialization by implementing this read object and throw an exception. If you do need to do serialization and deserialization, make sure that you whitelist, not blacklist, but whitelist only the stuff that you need that needs to be deserialized. And you can do that. I will not show you. You can do that by using, for instance, the validated object input stream. And this one is part of one of the Apache command libraries. But this is just one example. Then I'm whitelisting it, and then I'm only can accept the node class to be deserialized, right? But in general, I want to say, try to prevent Java serialization as much as possible. Just a few to go, just bear with me. Encrypting and hashing. And I will go to this one fast because this one is the most important one. Don't write your own encryption. Unless you are a cryptographer or a cryptography expert, you can write it yourself, but still don't do it. And again, you can use some low-level Java encryption capabilities that are there in the JDK, but it's kind of a hassle. It's kind of a hassle to do that, right? Just look for a few strong vetted libraries to do encryption for you. And there are a few. Basic encryption, say we need to have, most time we need to have something of two-way encryption. Say we have a credit card number, we want to encrypt it, but we need to create it back into a credit card number somewhere, right? That's two-way encryption. And again, encryption can be a talk on itself. And we need some sort of one-way encryption, hashing for passwords. Password, basically, if I have a password and I hash it, the same password would always have the same hash. So basically, I do not need the password. I just need the hash, and I can compare the hashes. If the hashes are the same, and if the password algorithm or the hash algorithm is strong enough, there will not be collisions. So say that hash is unique. I can just compare the hashes and see if that password is right or wrong. If it's a new password, it will give a completely other hash, and that hash needs to be strong enough that you cannot guess it. So it will not be a serial number that is increasing or something like that. So for instance, for two-way encryption, one thing I recommend is, and I talked this over with somebody like Germanico, and he said, like, take a look at Google Think. Google Think is an advanced encryption library from Google. I don't know if this is the latest version, but look at the latest version, of course, because they will improve anything. And you can do a lot of advanced, it will implement the advanced encryption standard, which is the standard for the US government. This is a code example of it, and it uses encryption with associated data. Well, it's a lot of code. You need to instantiate it once, but what it does is if you want to encrypt the plain text, I want to break free. And in this case, I encrypt it with associated data. That associated data is not encrypted, but you need it to decrypt it. You can just use the encrypt and decrypt functions of this library if you initialize it with the correct handles. And this is an example. I will show you the examples later how to use it, but using well-vetted libraries like this, and of course, you need to know what kind of encryption you use, and you need to review that decision every once in a while to make sure that it works. But you do not have to go deep into Java low-level encryption. You can just use some higher level standards and go back to the business logic that you need to write. If we go into hashing, we can simply use some stuff from the Spring data or Spring Security crypto library. This one is from version 5. And I'm using the bcrypt password encoder over here. By just using the bcrypt and password encoder over here, it will encrypt your password into a hash. You cannot decrypt it because it's a hash. And you need to match it using the encoder itself. Why? Because bcrypt is considered still one of the strongest algorithms to do hashing for passwords. It automatically adds things like a salt to your password. And that salt is there. So if you print out the hash every time looks different. But because the salt is in there to prevent things like collisions or rainbow table attacks, you need to encoder itself to do matching between the password and the hash. But it's as simple as these 3 lines of code. I see I'm already over time, so I will hurry into number 9 and number 10. Number 9 is the Java Security Manager. Well, Java has something like the attach API. If you are allowed to get into the machine where a JVM is running, with the attach API, you can attach to a running JVM, which is totally fine for some tooling. But if sometimes this is not allowed, or you don't want this to be, by default, this is on, unless you run the JVM with some restrictions. The attach API, just take a look at the attach API and see what's possible with there, because you can get into the running JVM and basically alter bytecode, right? And you can alter objects that are there. You can give it different values. You can, you can do a lot with it, which is cool if you are doing tooling. I probably think, and maybe Raphael can say that later to me, ByteBuddy is using the attach API, I assume, but it is there for a reason. But in many cases, these things don't need to be on. And you can say, well, nobody has access to my machine. Are you sure? Because if they have access, it's just an open door. You do not want to have one layer of defense. You want to have multiple layers of defense. An easy way to do this is to using the Java Security Manager. And you can implement the Java Security Manager by just running Java with this flag. Only if you do this, probably break everything, because the Java Security Manager policies by default are quite strict. So if you have an application that is, well, that security needs to be very high on, please look at this and look at Java security policies, and you can add policies to the default policies, or you can replace the complete policy of the security manager. But you basically can say which APIs can be accessed by this JVM, if I'm saying it correctly. But you basically can make sure that the attach API is out of scope. For instance, reflection is out of scope, but you need to do a bit of work on that. But with Java Security Manager, you can, for instance, exclude things like the attach API, which in my opinion, nobody knows, or a lot of people don't know that it's there and that it's activated by default. Last one, logging. Say a security incident happens. There's a lot going on, right? And probably the fix is a 2-minute fix, including pushing to production. Like, for instance, that add JSON ignore. I personally had that in one of my previous projects like years ago. We displayed too much, and we displayed a certain key into the raw JSON. The fix was 2 minutes, 5 minutes. That was including pushing it to production and make sure that it was live. The only problem was this: the questions next to it, the questions afterwards, the questions by my manager, the questions by customers, all the things, the aftermath took more time than actually fixing the stuff. Like, who was exposed? How long was it there? What was the impact? And most of your customers will ask if they are a victim or not. The problem was we didn't have enough logging on it. So the first thing we implemented was to log everything. Basically, every incoming call was logged. Who does this? Which IP? And we barely we set up live monitoring on that. So basically, what I want to say, logging too little is just as problematic as logging too much. Because if you log enough, and if you log, you make sure that the calls are logged, and you centralize that logging, you can do active alerting on it. Can you imagine that if people want to DOS you and you have no active alerting on it? If you do have active alerting on it, you may be able to make sure that a range of IPs is not able to connect anymore. So if you centralize that logging and you actively alert on things like log flat lines, high CPU, but also if a certain API or a certain IP is calling a certain endpoint 100,000 times a second, that a internal server that only needs to be reached by an internal other server is reached by an external server. Somebody is changing or is creating an SSL tunnel, an SSH tunnel towards a certain server. All these things we identified and we logged to make sure that if something is going to happen, we can make sure that it doesn't go worse and it's not going on and on and on and on, but we can intervene in time. If you actively alert on that, you might be able to scale down or to see that a node is harmed, and you can take that node out and maybe pop up another node. But you need to have enough logging to at least ensure that maybe nobody was hit. That vulnerability was there, but it wasn't actually utilized. If you cannot say that, then it's a hard time to explain it to your end customers, right? So centralizing logging And active alerting on it and make sure that you have enough locking is just as important as writing code. And these were the 10s. If you want to read more on this, we created a cheat sheet on that. It's called the 10 Java Security Best Practice Cheat Sheet. And you see the bit.ly link on top of the screen. But if you simply Google for 10 Java Security Best Practices or 10 Java Security, it will pop up, I think, as the first or the second hit. And we have inputted these 10 things I just showed you in a very small, digestive way. That was it. It's been a long. It's been a long one. I'm sorry for that, but I will stop sharing my screen so you actually see my face, and it's not a recording. I am actually here, and I'm giving the opportunity back to Dervis. So that was my story.
Thank you, Brian. Thank you so much for your presentation. I will open for questions now. If anybody in this channel has any questions, please write it in the chat area. And we have some questions from the YouTube stream, which I will. Let's start with the first one. Are the slides and code examples available?
I will make them available. I will make them available. They're not available yet because I just changed a few things, but they are available. They will be available. What I said, it's all based on a large post we created, I think, a few months ago. I created it together with Jim Manico. And that one is already on the internet. If you just look for 10 Java best security something, you will head up into the Sneak blog and you will have that cheat sheet. And basically all the examples are created from there. I just basically presented the research on this. So I will make them available, but if you want to, if you can't wait, you can go there already.
Thank you. The second one is, what are best practices for password storage in mission-critical Java apps, like vaults, hashed in databases, or something else?
Yeah, for passwords, first of all, use a strong cryptographic hashing algorithm. Bcrypt is one of these things, is an example. You have scrypt as well, but most important one, it needs to be a strong cryptographic hash, just not a random fast hash, because cryptographic hashes are quite slow. And there's a reason for that, because if somebody tries to brute force your stuff and that cryptographic hash is like super, super fast, they can just write a script on it. And if you use a strong cryptographic hash that is quite slow, if you type in your password once or twice, you do not actually feel it. But say if it's milliseconds or microseconds, the difference can be quite extensive for somebody who try to brute force your password. So that's one, strong cryptographic hash. If you go into secrets, say for connecting to database and that kind of stuff, make sure you have a vault. And that's a very good remark by the person over there. Yes, use vaults, and one of the implementation for Spring Vault based on the HashiCorp Vault is a very good implementation, in my opinion, to start with that. So for credentials, don't put your credentials in a property file or even not hashed. Put the credentials, put your secrets into a vault and connect to that vault, I would say.
Let's see. You talked about Google Think.
Yeah.
One example of crypto library.
Yeah.
There was a question early in the presentation whether you had any examples of libraries.
Yeah, well,
instead of the implementation.
Well, Google Think is a library you can use. There are a ton of examples out on the internet, and I just showed one of the examples, and I will show that is also available in that blog post I referred to. One thing that is important, I want to remark that what is safe now and what is considered safe enough now can be different next week or next month, right? So just like we need to review our code, and we need to update our dependencies, and we need to update into new Java versions, etc. We also need to make decisions on these algorithms if they are still strong enough. Because if I give this talk like 10 years ago, then I would say, oh, maybe not 10, maybe 15 years ago, I would say MD5 is perfectly fine. Nobody trusts us anymore, right? So that means that people try to crack this. And I will not, if the question comes up, if this, how quantum will infect us, that can be, I don't know. That's still looking into a crystal ball. But the point is, look at libraries that are vetted and well used by, well, the larger companies, but keep looking at it, and it's not a implement once, never look at it again. That's the most important thing I will have. Google Think is one of the encryption libraries that I think is useful. There are a bunch of them, but do your research if it's good enough for you, right? Because this is a general talk, and I can say that maybe if you work for the Ministry of Defense, your encryption level needs to be higher. Then you need to look into it. But please do not write it yourself if you're not a cryptographer. That's one thing that people try to do, like, I can do it myself. No, you cannot, unless you have a PhD in cryptography or something like that.
There's a question in the comment area here from Swayam. He asks, you talked about using JSON ignore at the source of data, but what about cases where this data is required by some other service?
Make sure you have a layer in between that does this for you. Most of the time, you can do two things. The question is, do you actually need it? Maybe create another service, because creating another service and make it single use, that can be one thing. And that's actually what we needed to, because we actually, this example is something I incurred like a few years ago. I think it was 5 or 6 years ago. And JSON ignore was the easy way out, because we only needed that reference ID that we pointed into the raw JSON. We needed it internally and not externally. So it needed to be saved with the object, but it doesn't need to be exposed. So the question there is, does it need to be exposed? And make sure that the mapping to the entity only shows what you actually need to show. And if there is an entity that you need to show in different ways, say that user thing, you need to say it. Sometimes it's the name and sometimes it's the address. Maybe you should cut that into two parts and make sure that the address is a different one and the user is a different one. So you need to take a look into your data architecture and see if you need these things together as an entity in your system. I don't say how you store it in your database. That's up to you. That's a whole different thing. But do you need it as a separate entity in your altogether into your system? And normally you should make a layer between what's the actual data in the database and what is the representation layer, right? And I did a quick one over here that integrates, basically cut the middle layer out just to make an example, because in most cases people just do a quick prototyping proof of concept kind of thing, and it works and it stays in production forever. And that's what you have to take care of. I hope that somehow answers the question, but it depends, as a good consultant would say.
There is 2 more questions. One is from from YouTube. What is the conceptual difference between steps and factor in two-factor authentication and MFA? Why those are factors and not steps?
Oh, that's a good one. I actually cannot answer that one. I have no clue. It's two-step. The question I want to ask back is, does it matter? The one, what are we trying? Naming is hard, right? And I don't know why it's called factor, to be honest. They called it multi-factor authentication or two-factor authentication because there are 2 equal factors in place that need to be done. And it doesn't allow you to do it in step 1 and step 2, but it can be the other way around. I have no clue. I'm just wild guessing over here. The most important part is that there is not just one single point of truth that is your password, but you have 2 different things that work atomically from each other to make sure that secure login is possible. And I have if you want to call it 2-step verification, I'm perfectly fine. But in my opinion, it feels like if you have 2 steps, the first one needs the second step. So that's what it feels. But I don't know why they call it factor. I'm just now trying to do it on the job.
Last question is, do you recommend encrypting variables in configurations via, for example, JSIPT?
That depends. That completely depends what the context is. Encrypting variables, now I wouldn't say encrypting variables if it's not needed. If it's like encrypting again, if it's encrypting credentials or encrypting secrets, I would use a vault. That's my one thing. So I'm not really sure what the person in this case means. If you need to encrypt stuff, then yeah, things like you do not want to if somebody gets your database, you do not want to get it out. That stuff you need to encrypt. Like credit card details is a very obvious thing, but there can be a lot of things in there. But that completely depends what you need to encrypt. It completely depends on your context, right? Because in some cases it doesn't matter. If I'm publishing my grocery list, nobody cares if the price is encrypted or not. You have to, and then you go back to the architectural layer that you need to see, like, what kind of data do I want to actually store? Do I need to store that data? What are regulations? Do I need to be compliant? Blah, 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 blah. That's more for the theoretical security agents that have a lot of degrees in that. But in practice, it depends on if it's obvious, then encrypt it. But encryption is also a thing, like, it can interfere with things like speed. So you need to take care of, like, do you want to have that? Maybe you shouldn't even store it. So there are a lot of loose factors in that.
Yes. Is there any other question that anybody wants to ask? Please ask it in the comment field now.
If you have questions later, feel free to ping me on Twitter. You saw my my Twitter handle @BrianVerm. You can freely ask me questions. My DMs are open. You can ask me questions over there. Feel free to ask any questions. And if you drop questions in the Slack channel, and well, Darvis or Raphael or Mark or whoever from the javaBin community sees a great question, they will refer it back to me. So don't feel afraid if you have to have a question tonight. I'm still trying to answer them.
Perfect. With that said, I want to thank everyone who joined our very first online meetup tonight. Thank you so much for being here. And I hope to see you next week. We will have Kevin Henny for our second meetup.
Wow.
And well, yes. So we have some amazing speakers lined up. And please follow us on Meetup or on Twitter. And feel free to ask any questions about our community. We are happy to answer your questions. And with that said, thank you and stay safe and have a good evening.
All right, thank you all for watching. It was a great honor. It was a great honor to be here and to be the first one. And I see there are a lot of great speakers coming up. So it's good that I'm not the second one. I don't want to be next. Don't want to be compared to Kevin. I mean, or Josh or whatever. But thank you for having me.
Well, the honor is ours. Thank you so much for contributing in this especially difficult times. And it was our honor to actually host you. And good luck ahead.
Amazing. Oh, well, have a great evening, y'all.
Yes. Good night and bye.
Bye-bye.